So today we will be seeing a very simple program of which will demonstrate the use of pre-trained model for prediction of an image. So we have two images here. We will demonstrate it whether our model can predict this image as what it actually is or not. So we will take a model that has already been trained and then we will feed this image through that model and we will see the results. We will be executing this program on Google Colab. So first of all, we will make a Google Colab file. Okay, we'll give it a heading, image prediction using pre-trained model. Okay, let's begin. First of all, let's see the steps that we'll be following. Step 1, load the pre-trained model. Step 2, load the image. Step 3, convert this image into numerical array form. Step 4, convert this array into input compatible with the model. And step 5, do the predictions. So let's begin. First we will import the libraries that will be required. Import numpy as np, import matplotlib.pyplot as plt. Next we are going to import TensorFlow. Import TensorFlow as tf. It is taking some time to connect here. Okay, it's connected. Once it is connected, it will be executing our program. Okay, now we will see which model. In our case, for demonstration, we are going to use VGG16. VGG16 is a model architecture which is based on CNN, which is having which are already trained by someone on the images. So it has been trained on the image database that are available on the ImageNet. First of all, let's see how to load this model on our Google Colab file. For that, we will go to TensorFlow documentation. See, here we have the code to load VGG16 in our file, in our project. We'll directly copy it and we are going to paste it here. So tf.keras.applications.vgg16, include underscores top is equals to true. See, this means that we have to keep the ANN network. If you see the VGG network image, see, this is the architecture of VGG16. This here is the convolution layer plus pooling layer, 2 convolutions layer, pooling layer, that way 3 convolution layer pooling, 3 convolution pooling, 3 convolution and a pooling layer. After that we have dense layer. These dense layers, this is the ANN, fully connected ANN network. So this whether we have to include or not, that is defined by include underscore top equal to true or false. Here, since we have made it true, it will include this also. Other option is that we can set it to false and we can make our own ANN network. In this case, we are directly using the pre-trained model without any modification. Weights equal to ImageNet. See, ImageNet is the image database, as I have mentioned earlier. It is having, it has been made by someone. If you put ImageNet on the Google, you will find it here. So our model has been trained on the images that are available on the ImageNet database. Okay. If you see the ImageNet object list, ImageNet classes list, these are the images, these are the labels that are available on the ImageNet. So if our if whatever the thing we have to predict, if it is available here, we can directly use our model. We can directly use our model for that prediction. So let's go back to the program. See, all these, even if we remove, it will directly load the default values. So just for the simplicity, I will be removing it. Since we have not specified any value, by default these values will be loaded. And this we will make an object for it, model, object name model. Our model is getting downloaded. Okay, so our step 1 is complete. Load the model. Now step 2, we have to load the image. For this also we will take the help of tf.keras TensorFlow. TensorFlow has the options or has the tools so that we can load the image and we can pre-process it also. For that we will do tf.keras load image. So here we have the syntax, here we have the code for it. We will directly copy it and paste it. These things we will remove it just to keep it clear. Okay. See, grayscale is equal to false, target size is none. Here we have to keep in mind that the target size should be according to the requirement of VGG16. When we see the documentation of VGG16, tf.keras VGG16, we see here that input shape. So in case this input shape we have to specify if we are saying include underscore top is false, but since in our case it is true, our input shape should be 224 and 3. So here when we are loading the image, we will specify this size. Here it will be 224, 224. Now we have to give it the path. To do this, look, first I will mount the drive. It will take some time. Okay, the drive has been mounted, and here we have to give the path of our file. My file is stored here somewhere in this file. So to get its path, you can look how I'll do it. Go to drive, go to my drive, navigate to the folder where you have stored your file, and this is my image, elephant. Just copy path and paste it here. You have to put it in quotes and we are done. We have to store this image somewhere, right? We will have to store it. So image for prediction, I'll store it in this variable. See, now we have to convert this image into numerical values, numerical array form. For that also we have option in Keras, image to array. So we'll copy the code format and we'll store image to array. Image in array is equals to df.keras.ml this image. Here we have to specify which image we want to convert. Data format, this will leave it to default values, not to worry about it. This is done. Let's check the shape of this. Image underscore in underscore array dot shape. So we see that the shape is 224 by 224 by 3. 3 specifies the 3 channels, that is RGB, since it is a color image. See, now there is a point to be noted that generally the image that is fed to the models, it has to be in the format as in a particular format where the first element is the number of images. Images height, length, width and number of channels. So for this we will do an operation called dimension expansion. Step 3, make the image compatible with the input of model. So I'll make a new variable, my compatible image, equals to np.extend underscore dimension I'll put this for what I have to extend this variable name, and axis equals to 0, that is on the rows I want it extended. Sorry, it is not extend, it is expand. Underscore dims. Okay, now let's check the shape of this. My compatible image dot shape. Okay, so see here, now this specifies the number of images, right? This is the format in which we can input it to the model. Now we will do the prediction. So prediction is equals to model dot predict the image, my compatible image. So the operation has happened, it has taken 975 milliseconds. Now let's see what is our prediction. See, this is giving the prediction in this form. We have to decode it. We will have to decode this. So for this also we have option in VGG16. In Keras we have option to decode it also. We will see here decode predictions. tf.keras.applications.vgg16.decode predictions, right? We'll copy it, and here we will print, right, paste it. In case of preds, we have to write this, our prediction, pred, and we have to execute it. So we see that it has given its top 5 prediction, that it has predicted it to be an African elephant with the probability of 71%. If you wanted to display only the single answer, we can do it in this way. We will just access that file 0, 0 and 1. See, it has predicted it as an African elephant. So we are now we also know that it has done a good job. Let's check it with the other image, that is of the tiger. Also, let's use a different model this time, with a different model, that is resnet50. So first we will see the resnet50. This here is the code to call the model, to load the model. I will make a new object called model1. Okay. All the parameters will set it to default values. If you don't specify anything, by default these values will be taken here. These values by default will be taken. The weights are used for the ImageNet training, from the ImageNet training. Load the model. Okay, our model has been loaded. Now we have to load the image. To load the image, we have load image, and we have to specify the path. For this, I will copy the path from here and paste it. I have to put it in quotes, single quote. Okay. And I have to save this image for prediction 1. We have stored it into a variable. If we want to see the image, we can do plt.imshow. plt.imshow image for prediction. One also I will have to add. Okay, so here it has displayed the image. Now we have to convert this image to an array form. For that we will use image to array from tf.keras. Yeah. So tf.keras.utils.image to array. Here we have to specify which image we want to convert. this is the one, and we'll store it into a variable image array 1 equals to. Okay, now we have to convert it into a compatible input form, or let us see what happens if we don't convert it into a compatible input form. Okay, so we'll directly call the model.predict. Model.predict image array 1. Sorry, we have to use model 1, right? Because our model we have changed. Model is VGG16, resnet50 we have done in model 1, right? See, there is one more mistake that I have done. When I was loading this image, I have to specify its size also, and that size I'll have to check it from here. When I see resnet50, here also we see the target size, the input shape has to be 224 by 224 by 3. So that I had to specify it when I was loading the image. I'll go back here, and here I'll specify that also. See, I had to give target size also. Here I'll put it as 224 comma 224, and then I'll execute it again. Okay, let me check the size of it. Dot shape, there seems to be some error. Oh, sorry, I can't check it for here. No, I have to check it after I convert it into an array. So that check I have to do here. Image array 1 dot shape. See, it is showing 480 by 640 by 3 because I have not yet executed this command. This cell has been executed on the previous image only. Now I'll execute this, and then let's see. Okay, now we have 224 by 224 by 3. Now we will execute here. See, we are getting an error. So the value error, input 0 of the layer resnet50 is incompatible with the layer. Expected shape is in this format, but found the shape in this format. So that is why we have to increase the dimension by 1. Make the image compatible with model input. So my compatible image 1 equals to np.expand dimensions of which one, image array 1 comma axis we have to specify for the rows. For rows, axis is equals to 0, and execute it. Now we will check its shape. See, there seems to be some issue. Okay. We have to check the shape of this one. See, we have one more dimension now. This specifies the number of images that we are giving. Now we will run the model. we have to run the model on compatible image. It is taking some time, it will take some time. Okay, it is done. Let's see what it has predicted, but before that we will have to decode this. For decoding again we will go to documentation of resnet50. We will check this is the code, we will just copy it and we will paste it here. We have stored it into pred only. Okay, see, so it has predicted it as a tiger with a confidence of 78%. If you only want to display tiger, we can use it like we had done previously, like this. Just have to copy this here, you have to paste it here, pred, then 0, 0 and 1. So that's all for in this session. If you have any doubts, any problem or anything you wish to know, you please just let me know. I will definitely look into it. If any mistake is also there, I will certainly will just have a discussion on it. Thank you.